Assalamualaikum warahmatullahi wabarakatuh, and hi, we're from Group 7. Today we'd like to present about our project, designing of a road drainage in the area of Kampung Sungai Yap, Pahang. So, before we start, I would like to introduce my group members. First, Muhammad Afif Hakimi bin Arsam as a group leader, Muhammad Khairul Ikhwan bin Wahidi, Muhammad Hazman bin Hasamuddin, Alia Elmina binti Muhammad Nur Azmi, Nur Amira binti Mazin, and lastly, it's me, Ini Nadia binti Ibrahim. So, what are we waiting for? Let's start!
I want to introduce and explain about introduction design of road drainage. Okay, first, provision for adequate drainage is of paramount importance in road design and cannot be overemphasized. The presence of excess water or moisture within the roadway will adversely affect the engineering properties of the materials with which it was constructed. Okay, second, cut or fill failures, road surface erosion, and weakened subgrades, followed by a mass failure are all products of inadequate or poorly designed drainage. As has been stated previously, many drainage problems can be avoided in the location and design of the road. Drainage design is most appropriately included in alignment and gradient planning. Third, to protect roads, irrigation systems, buildings, and fields, maximum rate of runoff for all drainage systems should be determined. Most structures can be flooded for a short time, but peak rainfall intensities and runoff data should be determined. So, the systems can be designed to handle the runoff. Fourth, it may be most economical to design the structures on a 10 to 25-year recurrence expectancy. That is, the expected runoff will be exceeded only once every 10 to 25 years.
Today I will present about purpose and objective for this project. Okay, the primary purpose of a road drainage system is to remove the water from the road and its surroundings. Dewatering means the removal of rainwater from the surface of the road. Drainage, on the other hand, covers all the different infrastructural elements to keep the road structure dry. Each group have to design and build a drainage system based on the floor plan that have been provided. To design the drainage system with some specification, two main resources have been provided, which is JKR Standard Drawing for Road Work Section 3 Drainage Work and JPS Urban Stormwater Management Manual for Malaysia 2nd edition 2012. These two sources are very important and very helpful for us to design the drainage. Okay, the main objective of this project is first, to calculate Q runoff that's suitable for design a drainage. Second, to find suitable drainage design that meets requirements state MSMA. Third, to determine the quantity of stormwater and wastewater originating from surrounding area.
Today I would like to present about methodology design of road drainage. Okay, firstly, the subcatchment determined by using the contour given. The highest contour on drawing choose and continuous line made that refer to 90 degrees. After drawing the line along the channel, the flow of the water will end up determined. The subcatchment area for each section be calculated to proceed the next step. The area must be calculated according to the shape of the channel, whether it is semicircle, rectangular, trapezoid or square. Next, average runoff coefficient, which is C, and average rainfall intensity, which is I, be calculated. The runoff coefficient is a function of the soil type and drainage basin slope. A segment of different land used within a subcatchment can be combined to produce an average runoff coefficient. The average runoff coefficient is estimated by C average equal to sum of AC um, over sum of A, which is A is area of segment. The rainfall intensity, which is I, is a typical from intensity or duration frequency curve for rainfall event in the geographical region of interest. The duration is usually equivalent to the time of concentration of the drainage area. The equation application is simple when analysis is prepared by spreadsheet. After getting information on area, which is C and I, calculate from flow rate for the catchment divide by section using formula QS equal to CIA over 360. The rational equation is a simple method to determine peak discharge from drainage basin runoff. It is the most common method used for sizing sewer system. Next, proceed to calculate the area catchment that were received by each channel, and proceed to the same step before, which is calculate flow rate for catchment by each channel, which is QC. There is additional channel in between CH0 to CH600 and calculate the area. Next, the flow rate for the additional channel be calculated. Lastly, suitable design choose for each type of drain, which are interceptor drain, bench drain, or roadside drain. The flow rate of the design calculate that had been chosen using formula QD equal to 1 over N AR power of 2 over 3 S naught power of 1 over 2. After that, compare flow rate of the design QD with QS and QC. Flow rate of design, which is QD, must be greater than QS and QC. If QD is greater than QS and QC, proceed to design the output of drain. If QD is less than QS and QC, other design of drain choose and increasing the design dimension of each drain.
Next, it is a process, step calculation, and result that has been derived from the project design of road drainage in the area of Kampung Sungai Yap. First step is determine direction of flow. We found out the direction of flow in the area with help of cross-section plan that has been provided. It contains 0 until 600 of chain each, and every chain each we divided into two parts, which is right hand side and left hand side. We use Excel. We made a graph to find the direction of flow easily, and the graph shows that the direction of flow of Kampung Sungai Yap, it initially rises and then it decreases, and it also indirectly indicates that the area of Kampung Sungai Yap is a hill area. Second step is drainage subcatchment. Based on the plan that has been provided, by using an AutoCAD, we determine the subcatchment by using the contour given, and the plan provided is divided into two parts, which is right side of the road and left side of the road, or you can call it as upstream and downstream. And we made the subcatchment divided into 12 subcatchments, which is 5 subcatchments for upstream and 7 subcatchments for downstream. And we determine the area for each subcatchment. And third step is a runoff calculation. It is a process calculation for flow rate runoff. So the first step of the calculation is after we determine the area for each subcatchment, we need to determine the developed area and undeveloped area for each subcatchment. We calculate the developed area by using a formula, area of road times length of the channel, while for the undeveloped area, we calculate it by using a formula, total area for each subcatchment, total area of subcatchment, minus developed area for subcatchment. So for example, subcatchment 1 for upstream, the developed area we get is a 0.02844, while for the undeveloped area we get 0.5338. Then the total area for the subcatchment 1 is a 0.5622. The second step is determine the average runoff coefficient. By selecting the runoff coefficient referring to MSMA table 2.5, we decided to choose the runoff coefficient for developed area is 0.95. It is for roads and highway, while for the undeveloped area runoff coefficient is 0.4. It's open space for forest cover. And we calculate the average runoff coefficient by referring to MSMA equation. Then for example, subcatchment 1 upstream, we get the average runoff coefficient is 0.428. Next is determine average rainfall intensity. How we calculate the average rainfall intensity is by referring the equation from the MSMA and the value of the formula of rainfall intensity. It's a constant value dependent on the rain gauge location, except for T and D that we need to determine on our own. T is the average recurrence interval, ARI, we choose 20 years, while for the D is a storm duration in hours, we choose 72 hours. While the other value, the constant value, it referring to MSMA table 2.B1, IDF constants in Pahang between 2 and 100 years, and storm duration from 5 minutes to 72 hours. Then we calculated, we get the rainfall intensity is a 3.5809. And the value of rainfall intensity it is the same for all subcatchment. And lastly is determine the flow rate for each subcatchment by using the formula referring to MSMA, Q equal to CIA over 360. C is a average runoff coefficient, I is a rainfall intensity, A is total area. An example for subcatchment 1 upstream, we get the flow rate of the subcatchment is a 0.00239 meter cube per second. And after that, we need to average of the flow rate. For upstream, the average of upstream 5 subcatchments, we get 0.002712. And for the downstream, average of flow rate 7 subcatchments we get 0.001377 meter cube per second. And lastly, the total average of 12 subcatchments we get 0.00193 meter cube per second. The fourth step of process designing of road drainage in the area of Kampung Sungai Yap is design calculation. It is a calculation process to determine flow rate of design. So the first step of the calculation is to determine the overland sheet flow path length, LO, for the flow path in every subcatchment to calculate the time concentration of each subcatchment. It can be determined by referring to the subcatchment that has been made by using an AutoCAD. And the second step is determine slope over land surface in percent, and it can be calculated by using a formula, highest contour minus lowest contour in the subcatchment divided by the length of overland sheet flow and time 100%. So for example, subcatchment 1 in upstream, the slope over land surface we get is equal to 15.31%. And the third step is determine overland flow. Overland flow can be calculated by using a formula, overland sheet flow travel time in minutes equal to 107 times Horton roughness time length of the overland sheet flow power of 1/3, and all of them divided by slope of overland power of 1/5. The value of Horton's roughness can be referred to MSMA table 2.2. We decided to use 0.045. It is an average cross. So for example, subcatchment 1, upstream, the overland flow that we get is equal to 11.32 minutes. And the next step is to determine channel length, which is LD, for the channels in every subcatchment. It also can be determined by referring to the subcatchment that has been made using an AutoCAD. And the next step is to determine the friction slope of the channel by dividing the different elevation by the length of the channel. For example, subcatchment 1, upstream, the friction slope that we get is equal to 0.1056 meter per meter. And next is a proposed design drain. So we decided to go with shoulder drain type 1. We calculate the wetted parameter of the shoulder drain, area, and the hydraulic radius. So the wetted parameter of the shoulder drain type 1 is a 0.9 meter, and the area is a 0.09 meter squared, and the hydraulic radius is 0.1 meter. And the next step is a calculate travel time in channel of the drain. It's a TD. It can be calculated by using a formula, Manning roughness, time, length of bridge, and all of them divided by 60 time hydraulic radius power of 2/3, and slope and the friction slope power of 1/2. So the value of Manning roughness, it can be referred to the MSMA table 2.3, and we decided to go with 0.015. It is a concrete and smooth finishing. So for example, subcatchment 1, upstream, the travel time of the subcatchment we get is 0.31 minute. And the next step is calculate time of concentration for each subcatchment. It can be calculated by using a formula, overland flow plus drain flow. It's a TC equal to TO plus TD. And for example, subcatchment 1, the time of concentration for subcatchment 1 upstream is 11.63 minutes. And then we calculate the velocity of the subcatchment. The velocity of subcatchment, the velocity can be calculated by using a formula Manning equation. It is 1 over Manning roughness times hydraulic radius power of 2/3, and times friction slope power of 1/2. So the Manning roughness is, as we decided to go with, 0.015. So for example, subcatchment 1, upstream, the velocity that we get is 4.667 meter per second. And then after we get the velocity for each subcatchment, we need to average the velocity for 12 subcatchment. And the average velocity for 12 subcatchments has been calculated, and it is equal to 3.824 meter per second. And it has to be tracking either it meets the requirement or not. And lastly, we need to calculate the peak discharge using the formula Q equal to AV. It's a peak discharge is a flow rate of design by using formula Q equal to AV. A is the area of the drain type that we choose, and V is the velocity of the subcatchment. So we need to calculate the peak discharge for each subcatchment. For example, for the subcatchment 1, the peak discharge that has been calculated is equal to 0.2 meter cube per second. And after that, after we calculate for the every subcatchment peak discharge, we need to get the average for the 12 subcatchments peak discharge. So the average peak discharge for 12 subcatchments is equal to 0.3442 meter cube per second.
Now, I'm going to explain the discussion part for the calculation. Before the proposed drainage design is chosen, the calculated runoff flow rate for both upstream and downstream at the location area is 0.00193 meter cube per second, and the calculated average of flow rate for catchment is 0.21 meter cube per second. The chosen type of drainage that has been made is shoulder drain type 1, where it has fulfilled all the requirements needed. Shoulder drain can collect the water flow from the surface of the road. According to JPS Urban Stormwater Management Manual, 2nd edition, Chapter 6, Clause 26.3.3, the maximum depth for line open drains shall be in accordance with the recommended maximum depth. The recommended maximum depth for drain without protective covering is 0.5 meter, while drain with solid or graded cover is 1 meter. Based on JKR standard drawing for drainage work, shoulder drain type 1 is a cast in situ U drain with a standard depth measurement of 0.3 meter. Therefore, it has met the requirement which it doesn't exceed the maximum depth for both type of cover condition. To prevent sedimentation and vegetation growth, the minimum average flow velocity design drainage should be in the range of 0.6 meters per second to 4 meters per second. Based on the calculation, the average flow velocity for shoulder drain is 3.82 meters per second, which is still in the range of the required velocity. For the design, drains shall be provided with a 1.2 height handrail fence on graded covers for the entire length for public safety as the velocity exceeds 2 meters per second. The flow of the design drainage shall be greater than the flow rate of runoff and subcatchment. Shoulder drain type 1 has a flow rate of 0.3442 meter cube per second, which is greater than flow rate runoff of the channel. Q drain must be greater than Q runoff because the main problem is the area regularly occurs overflowing of water at the channel. Therefore, we need to find the suitable design of drainage so that it can accommodate and withstand the amount of rainfall, water volume, and water flow at the area.
So I will continue the presentation with conclusion. So first, the main objective of this project have been achieved, which is there are three main objectives. First, to calculate Q runoff suitable for design drainage. Number two, to find a suitable drainage design. Number three, to calculate the quantity stormwater and wastewater originating from surrounding area. And the drainage in Kampung Sungai Yap has been designed properly according to the standard and drawing provided, and we have discussed, and the shoulder drain has been choose. We will use the shoulder drain for this project, and the choice has been considered all surrounding factors such as land surfaces of this area, number two, rainfall of the area, and number three, the water flow. Land surfaces of the area is for to determine to assume the direction of water flow, which is from higher ground to the lower ground. The rainfall of the area to calculate the rainfall intensity. And number three, the water flows. We want to know which water will flow into the drainage. And the importance of design calculation. From the calculation, we can choose the best and proper design. Why it is important to choose the proper design? It is because we can prevent from erosion of the road and the road shoulder. We also can prevent from reducing of bearing capacity of the subgrade and road structure. And lastly, we can prevent from deformation of the road. As we all know, this problem caused by the uncontrolled water flow on the road.
Thank you.